Hi, Ramesh Anavatala again. In my previous experiment, I was discussing about the PIC16F84, and I was showing you the how the LEDs can be. I mean, we can blink the LEDs. And one of my friend, he was concerned about that one. It was not good product, and I thought by using the PIC16F88, if we can read the temperature of the outside, I thought it would be a nice project. Okay, let's look at the project. And one more thing is in this video, I mean, in the last video, I didn't show you much of the information about the how to the GUI, the interface for the programming and the programs test circuit, all of those. In this experiment, we can go through everything. What is the peak? What is the peak controller? What we can do? What are the limitations and how we can do? Let's go. And let's start our presentation. Okay, introduction. The microcontroller contain a CPU, central processing unit. You might know every computer has a CPU, and it has a RAM and ROM input output lines and serial parallel ports, timers, and in fact it has A to D converters and the D2A converters. And if you look at all these components, and it's the same as our computer, so you can treat this one as a small computer. The microchip can be treated as a small computer. Okay, and here are some features. Pick microcontroller. I mean, each of the feature I put it in a table. Flash memory, which we can be reprogram each, and the RAM, which is a permanent. I mean, which we can be the RAM which reads the program, and the EEPROM, and the electronic erasable programmable read-only memory, and the input-output ports that we can use for the communicating the outside world, and the timer which is inside the chip to compute all the delay and everything, and user to use the RS-232 port so that your computer or the outside world can read it. And there are a couple of others too. If you notice the A2 ADC, I mean that's the feature that we are going to use, and like the rest of the features, if you want, you can Google that one. Okay, this is the chip what we are going to use for our experiment, PIC16F88. What we can do with the microcontroller, we can do anything with the microcontroller. Here are some samples. A to D conversion, analog to digital. Example: read a temperature, read a pressure, read a sensor, read a rotation, tilt, motion, speed, and the time, fingerprinting, barcode, reader, touch screens, anything you want. You can read from the chip, but the chip you're going to use has to support all of those. Okay. How complex it is? If you follow a few simple procedures, it's very simple to talk with these chips. For programming a microchip, you must have one of these programming languages, such as assembly, C, BASIC, Pascal, or VB. I mean, you might be knowing, if you need to program these chips, you need to know one of these program, of course. I mean, I use the C because it's simple, and most of the people they may use the Visual Basic too. And the assembly language, you can use it by a little bit, kind of people feel tough. Okay, tools needed for I mean any chip for this experiments. We need a microchip, of course, the the prime processor. PIC16F88 or PIC16F84A, um, PIC16. There are so many, 8-bit, 14-bit, and 12-bit, 16-bit process, a 32-bit process, um, and the 64-bit process, of course. Your program that instruct the PIC what to do. The and the other one is the actual program that you wrote. I mean, you write for the PIC. We need that one. The output is going to be HEX. So whatever the programming language you use, like assembly, C or VB, the final output is going to be in the HEX file. And this HEX file we write into the PIC. A programmer. Okay, we need the other one is next one is the programmer. You need one programmer in order to, so there must be a bridge between your PIC and your program, whatever the software you wrote. And there is a bridge. You need to send this program into the chip. So there you can you get the programmer. The programmer sends all this uh, software into the chip. Programmer, you need a programmer or a burner that will send you file instruction into the chip. Example, you can buy a simple one from Amazon, which is a kind of kit USB PIC programmer. You can stick to your USB port in your computer and send those files into the chip. Just put that chip into the programmer and operate their software. Optionally, you can simulate the program with the Proteus. I mean, I do. I generally do the simulation because it saves a lot of time. You can do the simulation by Proteus. It's a nice program. I'll show you in my presentation later on. A test circuit. After you burn this PIC, you need to test it out, of course. Here is the block diagram. You have your programmer HEX file, and you have USB programmer that you buy. So I mean, you can prepare my yourself. I use PIC Kit 2. It's from Microchips. It's because I use this one because it supports lots of microcontrollers. Here is the steps. Select a chip that is suitable for you. The first thing thing is we need to select the chip. Okay, what how I mean how do I select the chip? It's depend upon what are the requirements. If you need a to D conversion, like I need for this experiment, I mean you need to select a chip that has that feature A to D conversion. How do I know that? You need to look at the data sheet of that PIC. Okay, so here is the data sheet for the, of course, for the 16F88 that I'm going to use in my and it has if you look at the ports, there are pins 1 2 3 4 5 6 and 8 18 pins, and it has two banks of A and the B. Port B has 8 pins, starting with the 6 to 13, and the port A has how many bits? 1 2, the same. Okay, the same 8 bits. And if you look at the port 1 2 3 18 and 17 are A to D converters. And the step 2, second step is select a programming language. And the language is I already told you, like a assembly language, and the C, Visual Basic, and there are Pascal too. I mean, there are so many programs, but the main aim, all of them is to create HEX file. Okay, step 3, they select the IDE for programming. To make your program very simple and debug all the programming errors, you need a IDE. MPLab is the one for doing such. I mean, it's a free software. of course all of them are free, but ITEC-C, these are the limited versions are free. Like ITEC-C has a limited version that is a free. Micro C has a limited version that's a free. I use Micro C because I'm familiar with that. Okay, if you look at the MPLAB GUI, it looks like this one. If you look at the, they have all kinds of features like watch the each resistor, the register, and the functions registers. There are so many features. Okay, here is this is the programmer step. Selecting a programmer, you can choose a programmer, any kind of programmer. You can make a one if you want, but it takes time. This is, you can buy pretty cheap. These are pretty cheap. You can buy one from Amazon.com or anywhere. All you need is check whether your chip is supported with that, board. And step 5 is the simulator. I use the simulator for this. There it looks like this one, and you can create a PCB out of it. That's a nice feature. And the test circuit. This is the test circuit. If you look at the once you burn the chip and you have a chip, now it's time to run the chip, like the test it. You can make any. You can make a, once you test it out, you can make this as a production, like you can start doing producing these chips. Okay, in here, if you look at the diagram, this is the simple LED blinker on port A, 0 bit. Okay, so pretty much it. Okay, we are enough with the theory, and we are done. We saw everything. Let's try a live demo. Okay, what do you need for this live demo? I'm going to be using, these are the components. This is a component name, part number, and quantity. We need a one PIC16F88 and part number, you can see, and we need one resistors. We need a 2.2K 8 resistors. You can use pretty much any company, but and 7 segments is a common anode, 7 segments, 7 segment LED display. We need 2 in order to display the temperature. And the resistors, I need a 10K resistor, 1 resistor, and transistor BC557. This is a PNP transistor. 2, we need temperatures, and we need finally a temperature sensor. That's a LM35DC. Okay, the program is going to look like this one, and the test circuit is test diagram is going to look like this one. That's it.